All right, so last class we talked about trig ratios, and today we're going to kind of take a step back and look at some special characteristics and some special ratios that can be formed when you have similar right triangles. So again, remember similar being the same shape, same angles, but different side lengths. But the side lengths are equal in proportion, okay? So quick review of simplifying a radical. So obviously you can type this in your calculator, or you can simplify it. And the way we simplify a radical is you kind of do a tree diagram. And so I know that two numbers that go into 20 are 2 and 10. And then 10 can then be simplified to 2 times 5. When you have a pair of 2's, 2 times 2 is 4, and then the square root of 4 is 2. So you can call, we call that pulling that out in front of the radical. So these two pair of 2's come out in front as a 2, because the square root of 4 is 2. And then what's left behind stays inside the radical, so this would be the 2 the square root of 5. And you can check your work by multiplying in a circle. 2 times 5 is 10, and then 10 times 2 is 20, which brings us back to where we were. Or obviously you could just type in the square root of 20 in your calculator. And when you do that, you should get something around 4 point something. Square root of 72, again, you can apply it the same way. You're looking for perfect squares within 72. 9 times 8 is 72, then 9 is 3 times 3. And then 8 is 4 times 2, and 4 is 2 times 2. So I can pull out a pair of 2's and a pair of 3's out in front. So I'm going to pull out 3 times 2, and this 2 here is going to stay behind. Well, 3 times 2 is 6, and the square root of 2 stays behind. So if I want to simplify the square root of 72, you get 6 square root of 2. I can check that by multiplying 6 times 2, which is 12, and then 12 times 6 is 72. 72, and I end up back where I started. Okay, or obviously you can type it in your calculator, and you should get, let's see, 4964. It should be 8 point something. And this one, 4 point something. Okay, so that's a review of what we learned in the past. Now we're looking at solve for x. Now there's, this is a right triangle. I don't have any information about any angles other than the right angle. And so therefore I cannot use trig to solve this. I actually have to use the Pythagorean theorem. So I'm going to call this side A, this side B, and this has to be side C because it's across from the right angle. So this would be 60 squared minus 36 squared, and that's going to equal x squared. Again, I don't have a calculator, but you can type this in your calculator exactly how it looks. And then the last step is to take the square root of whatever you get. All right, quick review. Let's move forward. Today, like I said, we're going to look at similar right triangles. Just like we learned our trig ratios yesterday, we're going to learn special ratios that can be formed from similar right triangles. All right, so right here I have triangle ABC. It is a right triangle. Angle B is a 90-degree angle. All right. So the first thing I'm going to do is I'm going to draw an altitude. So an altitude is actually a line segment that goes through the vertex and is perpendicular to the opposite side. So I'm going to draw a altitude right here at angle B, and that's going to be 90 degrees. Now if you'll notice, at this point I've actually got 3 right triangles. I've got this little one here. Okay, and then I've got a middle-sized one here. And then I'm going to outline the gigantic one in blue. Okay. So there are my 3 right triangles. And you can go ahead and draw them below if you'd like. The big triangle would be here. This. A, B, C. And then this would be little side A, little side B, and this would be side C. And then I've got the left triangle, which I outlined in red. And that one looks like this. So I'm going to call this D. This would be D, B, A, and again this is A, this is B, and this is side C. And then I got the third triangle, which I colored in green. And that's the second half of the big triangle, B, D, C. This is side C, this is side B, and this is side A. Okay. So that's kind of what you get. Now we're going to talk about what a geometric mean is. So it's a special way of cross multiplying, and then you find the square root. So when you set up these ratios, once in a while you're going to get a situation where you get like a number over x equaling x over a number, a different number, right? So if you cross multiply, you actually get x squared is going to equal a times b. So the last step is you're going to have to take the square root of both sides to figure out that x is going to equal the square root of a times b. Let's put numbers into this because that kind of makes it less confusing to me. So if I use the numbers 3 and 4, and I want to find the geometric mean of 3 and 4, you would do 3 over x equals x over 4, right? So 3 times 4 is 12, so you get x squared equals 12. Well, the very last step then is you'd have to take the square root of both sides. So x is going to equal the square root of 12. Okay, so a cool relationship is that if you are trying to find a missing side and you're giving an altitude, you can actually set up a ratio side over altitude equals altitude over side. So once again, we have to understand that this is our altitude, right? And this is our side here and our side here. So if I were to set up this ratio, I'm going to do my side 2 over my altitude 7 is going to equal my altitude 7 over x. All right. And to solve this, again, you're just solving a proportion. So I mean, 7 times 7 is 49. So it'd be 2x equals 49. And obviously you're going to come up with a decimal. X is going to equal 49 divided by 2. And again, I don't have a calculator, but you can type it in. And whatever you get when you divide 49 by 2 is your answer. Over here, once again, I've got this altitude dividing my two sides. So it's going to be 3 over h equals 9. I'm sorry, h over 9. And this time, I'm going to have to find the geometric mean. So h squared equals 3 times 9, which is 27. So I'm going to take the square root of both sides. So h is actually going to equal the square root of 27. And you can figure that out by typing it in your calculator. Right, down here, it's the same situation, except my picture is turned. Okay, and now look, I know that this side is 9, and I know that this whole side is 25. So to figure out the other side, I simply have to take 25 minus 9, and that should give you 16. Now I can set up my ratio of 9 over x equals x over 16. This is a little bit different than when you're setting up a proportion when you don't have a right triangle, because then you do this over this equals this over this, right? So it's a little bit different, so don't get confused. This is specifically for our right angle, similar right triangles, and an altitude. So this would be x squared equals 9 times 16, which I didn't figure out, 6, that's 54, 9, 10, 11, 12, 13, 14, 44. Well, this one's going to come out nice and pretty. Take the square root of both sides, so x is actually going to equal 12. All right, and once again over here, I've got my right triangles turned. It's going to be the same situation. I'm going to subtract 36. 3 from 9. So this would be 36 over x equals x over 64. And again, I didn't work it out mathematically. You can do that with your calculator. So that's how you find the missing side length when you're given an altitude. Next situation we're going to look at is if you're given a hypotenuse and a leg. But notice, the difference on this one is the altitude is not given. Okay? On here, notice the altitude was labeled. These, the altitude, are not labeled. So the first thing you're going to do is look at the hypotenuse of the big triangle. All right, so I've got the hypotenuse on the big triangle is this big side right here. So that's my first, 13, over my leg, which is right here. Now that's actually the hypotenuse on the little triangle, but it's the leg we're going to use again over the missing side, which is x. So this would be 13x equals 25, and then you divide by 13 and you get what x equals. And I'm not going to do it because I didn't work it out. Right, over here again, you're going to look for the big hypotenuse. So that's this big side over here. So that's x over, now the leg on that triangle is 36, which is actually also the hypotenuse on the other triangle, so that's why it comes again. And then we're going to put that over 33. And again, you're going to cross multiply 33x equals 36 times 36. And then the last one, once again, the altitude is not labeled. So to figure out what x is, the first thing we have to do is look at this hypotenuse here. So I'm going to actually add them together to get 10. So 10 over the side of the big triangle is x. Now x is also the hypotenuse of the middle-sized triangle over the side length, which is 8. So I'm not using this triangle at all except to figure out what the hypotenuse is. So this would be x squared equals 80, and then you'd solve that by calculating the square root. So those are the special ratios we're learning today. Hypotenuse, leg side, and the other one, again, we have a little bit of a mixed match of problems, and then we also have radicals in this. Now, using a radical, when you're multiplying, you have a calculator, so it should be very simple. So once again, I'm going to look to the altitude, and I notice the altitude is not labeled here, so I'm going to have to use hypotenuse leg. So the hypotenuse is on the big triangle is x, and the leg is 7 square roots of 33. So I'm going to start with 7 square roots of 33 because that's now the hypotenuse in the middle triangle, and that's going to be over 33. And then you're just going to cross multiply. So you're going to get 33x equals the square root of 33 times the square root of 33, I know is 33, and 7 times 7 is 49 times 33. And then when you divide by 33, you'll end up with x equals 49. Okay, and over here, I notice that I have an altitude, and I'm looking for this side over here. So this is going to be x over 6, the square root of 13, equals 6 times the square root of 13 over 13. When I cross multiply, I get 13x, and that's going to equal 36 times 13, because the square root of 13 times the square root of 13 is just 13. And so in this case, x is going to equal 36. All right, the next set of problems have some extra information that you're going to need to ignore. Okay, so in this problem, again, I'm looking for an altitude. So this would be 5 over x equals x over 13. Cross multiply and take the square root, because you're going to get x squared equals 5 times 13. Right over here again, I'm looking for a hypotenuse, but I know that this leg is 10, the whole thing is 24, so I have to know that this side is 14, because 14 plus 10 is 24. So you get 10 over x equals x over 14. And then again, you're going to get x squared equals 140, and then you have to take the square root to figure out what x is. Over here, I don't care about the altitude. What I care about is this side here. So I'm going to have to add to find the hypotenuse, which is 92. And I end up with 92 over x. And then x is now the hypotenuse in the smaller middle-sized triangle, x over 70. And again, cross multiply and divide. All right. So you're going to need to finish the work and then check the board for the IXL. Get your work